Hi there, this is Penelope. This is question 2 of Test 2, Trimester 2, 2021 for NZDE4102. And remember, it's following the exam from 2020. Okay, now we're doing integration, and you need to remember that that is the instruction about what you need to do. And you may well find that it's easier to rewrite the question. Maybe, I don't know. Possibly not for the first two terms, but certainly for that one, because that's the one that is very often incorrectly done. Okay, now remember the integral of x, or ax to the power of n, is ax to the power of n plus 1 over n plus 1 plus c. So it will be 4. Now remembering that it is a negative power, and this is why maybe for the first two terms it's easier to leave it as it was, that becomes negative 2. The next one is, and that would be over negative 2. The next term will be 3x to the power of negative 1 over negative 1, but we could sort of short circuit that and write that as minus and have that just as 1. The next one is on the formula sheet. So that's where you've got 2 natural log of the absolute value of x. If it's not with the absolute value signs, I tend not to do it myself, and as I explained when I taught this, I tend to know that x can't be negative, so I just don't put them. But to be strictly speaking correct, but not wrong in the exam, you need to write the absolute value signs. And then there was half a mark, half a mark, half a mark, and half a mark. Now you could have gone further, and you could have left this as negative 2x to the negative 2 minus 3x to the negative 1 minus 2 natural log x plus c. That's also correct, but not necessary. For section B. Okay, finding the area. Now again, it's integration. So that the area, now you should have done a quick sketch of this as part of your working, but it's not for mark, so I won't include it here. It's the integral between 4 and 9. So I'll put over here in your working, but not for marks. Do a quick sketch. Okay, so it's the integral between 4 and 9, or 9 and 4, of x to the negative a half. And once we've done that, that becomes x to the half over a half. And we don't need to put in plus c because we know that it's going to drop out. And simplifying that, it becomes 2x to the half from 9 to 4. Okay, now it's just number crunching. We're going to put in there, it's going to be 2 times 3 minus 2 times 2, which is equal to 2 units squared. And make sure you put this bit in. Okay, it's really important. It didn't lose you any marks here, but it may well in the other questions. So you got half a mark for finding that, half a mark for doing that, and a mark for doing the calculation. This one required you to recognize that the only way you could do it was by substitution. So it's integration by substitution. And no matter which other way you tried it, if you had checked your answer wouldn't have been correct. So this is the only way that you can do it. So what you could say was let u equal sine r. And then remember we find du by dr, and that's going to be cos r. And then we really need to find dr, so that's over 1. So dr times cos times du equals du times 1. So we need to find dr. dr is going to be du over cos r, and that's your working before you can start. Now you can say that the integral of sine squared r cos r dr is equal to the integral of u squared cos r times dr, which we now know as being du over cos r. And this is why we do it this way, because we know that the cos r and the cos r are now going to cancel out, and no other way helps us as much as this. So now we have the integral of u squared du, and that's easy. That's u cubed over 3. Now, I'll just go back. This is indefinite integration, so we don't have any numbers to put in, so we're fine to not have to worry about those. If we do have the numbers, we do have to worry about them. We don't in this case, so we do need to remember though to put in plus c. Go back and rewrite it then. U was sine of r, and it's over 3 plus c. So that pretty much was worth 2 marks of that. But don't forget, every time you leave off c, it's minus half a mark if there's no c. Second to last question, penultimate is the word. Okay, so pi is a number, so before you start on your integration, you can take the pi out the front. So it's pi by 4 to 0 of sec squared t. And this is on the formula sheet, so you know that the integral of sec squared is tan. So it would be pi times tan t. Make sure you don't change it to x. Students are very happy to just go, oh, it's always about dx, but it's not. And that this is going to be between pi by 4 and 0. So taking the pi outside that, then we have pi times, putting in pi by 4, don't forget your calculators in radians, that's going to be 1 minus 0, which is equal to pi. Some of you put it as 3 point whatever in decimals, that's fine, but you're getting a mark for the integration and you're getting a mark for the answer. So you could have had decimal equivalent, to 3 significant figures, remember. The last question, last part of this question is a quotient. Now, we don't do quotient rules in this course, so you need to kind of think about it in a different way, because actually it's going to end up as integration by substitution. All right, so let's rewrite it as it's the integral of natural log times 1 over x, and I just might put that in brackets so we can see it like that. Remember, this method works when you can spot the function and the derivative of that function. So that's what you're looking for. Look for a function and the derivative of that function, and that tells you to use substitution. Sorry about the phone call. Okay, so once we've set it up like that, we can see that this one is the derivative of the other one. So if we say let u equal natural log of x, then du by dx equals 1 over x, and that will tell us that dx is going to equal du times x. Putting it all together, then we have the integral of u times 1 over x times dx, which we need to substitute back for du times x. And you'll see then, again, this is what we needed. We needed the baddie, the x term, to cancel out. So now we have the integral of u du, which is easy enough to find using the normal rule. That would be a half u squared plus c. We need to backwardly fill it. That will be a half natural log of x squared plus c. So a mark for kind of showing that you were thinking it was like this, and a mark for getting the integral right. Now, don't forget, you will lose half a mark if C is missing. Okay, that's the end of the second question.